In previous video, we learned that ChatGPT breaks text into tokens. But tokens alone don't carry meaning. For example, how does AI know that dog and puppy are related? Or that car and vehicle mean almost the same thing? The answer is embeddings. In this video, we will understand one of the most important concepts in modern AI. A quick recap to start understanding embeddings. In our last video, we saw that text becomes tokens and every token gets a numeric ID. For example, dog has a token ID 432, cat has a token ID 278. But here is the problem. Does 432 tells us that dog is an animal? No. Does 278 tell us that a cat is similar to a dog? No. These numbers are simply identifiers. They are like employee IDs. If your employee ID is 123 and mine is 124, that doesn't mean we are similar. So, token IDs don't contain meaning. Now, when humans hear the word dog, our brain automatically connects it to many related concepts: animal, pet, barks, four legs, loyal. We don't think only about the letters DOG, we think about its meaning. AI needs something similar, and this is where embeddings come in. An embedding is a numerical representation of meaning. Instead of giving every word a random ID, AI converts words into numbers that capture their semantic meaning. Imagine placing every word on a giant map. Words with similar meanings are placed close together. Words with different meanings are placed far apart. So, dog and puppy are neighbors, but dog and truck, aeroplane are far away. Here, look at the ID assigned to dog, which is 0.82, 0.31, 0.66, 0.14. Instead of a token ID like 432, the model generates an embedding. This is simply a list of numbers, but unlike token IDs, these numbers actually represent meaning. Notice something interesting here. The embeddings for dog and puppy are very similar because dog and puppy have similar meanings, whereas the embedding for airplane looks very different because airplanes and dogs are unrelated concepts. You may wonder why embeddings contain hundreds of numbers. The answer is simple. One number is not enough to describe meaning. Imagine describing a person. You would need height, weight, age, profession, location, languages. One number can't represent all that. Similarly, AI uses hundreds or even thousands of dimensions to capture the meaning of a word or sentence. Embeddings are not limited to individual words. We can generate embeddings for entire sentences, even paragraphs, and entire documents as well. Now imagine someone searches, how do I reverse a string in Java? But your documentation says Java string reverse. The wording is different, but the meaning is almost the same. Embeddings capture meaning, not exact words. This is why embedding based search is much smarter than keyword search. It understands meaning, not just matching words. Here we can search with reverse string, flip string, string reversal, invert characters, and all will return the same answer, which is for the question how to reverse a string in Java. And that's why embeddings is powerful. A real life example would be when customer asks how to reset password. Even though the customer never used the words forgot password, AI still finds the correct article because both sentences have similar meanings. Embeddings power many modern AI systems. Semantic search, recommendation engines, retrieval, RAG, and vector databases. Many beginners confuse token and embedding. A token is simply a piece of text. An embedding is the mathematical representation of its meaning. Tokens help AI read text. Embedding help AI understand its meaning. And we need both. Let's connect everything we have learned so far. Your sentence is split into tokens. Each token is converted into an embedding. Those embeddings are what the model actually processes, the numbers. This is how AI begins to understand relationships and meanings. Now we know that embeddings are vectors representing meaning. But where do we store millions or billions of these vectors? Can we put them in MySQL or Oracle? Not efficiently. In next video, we will learn why vector databases were created and how they make semantic search and RAG possible. Thank you for watching. See you in next video.